All right, now we're learning about complex numbers, and they're actually not that complex. Make sure you write down the basic formula or formatting for a complex expression. It will look like a plus bi. The a value is your more real part. It's the real portion, real part of your expression here, and bi is your fake. No, it's not fake. It's imaginary, which is not fake. It's just the imaginary space. It's a different dimension, imaginary part. All right, so let's go ahead and do a couple examples. Say you have 3 plus 5i, add 4 minus 6i. Well, you're going to add your real numbers, 3 plus 4. Make sure you're coding. You can do any coding you like. I'm doing squiggly lines and lines. And you add your 5i minus your 6i, right? And then that's 7. 5 minus 6 is negative 1i. So we call that 7 minus i. Now, if your test asks you for the b value, well, a plus bi, right? Your b value, this is your answer. You're looking to simplify this expression, which would be 7 minus i. If it does ask you for the b value on a test, it's whatever number is in front of your I, which is negative 1, right? Negative 1. So negative 1, not negative 1i. Your b value is not negative 1i. It's not true. Wrong. It's negative 1. Let's try another one. If you have 4 minus 7i plus 2 plus 3i. Well, let's add up our real numbers. 4 plus 2. And then negative 3i, negative 7i, negative, keeps with the number, plus 3i. That'll give you 6. Negative 7 add 3 is negative 4i. So your b value, if it does ask you, this is your answer, will be negative 4. One more. Say you have 5 plus 2, 5 plus 8i, and you're adding, I don't know, 4 minus 2i. Well, add your real numbers, 5 plus 4, and then add your imaginary, positive 8i minus 2i. That's 9. 8 minus 2 is 6. There's your answer. If a test asks you for the b value, it's positive 6. Okay, we're going to go ahead and go into multiplication now. What if you have 4 plus 6i and you're timesing 3 minus 5i? Well, 2 parentheses means multiplication. So do your arrows, your rainbow. 4 times 3 is 12. 4 times negative 5i is negative 20i. Positive 6i times 3 is positive 18i. And then 6i times negative 5i is minus 30i squared. I times I is I squared. You can keep these just like, think of these like x's. 6 times negative 5 is negative 30. X times x is x squared. It's the same idea. Now we're going to go ahead and simplify down more. Make sure you go ahead and circle your I squared. That's important to know. So, I is the square root of a negative 1. Watch my imaginary video if you don't understand that. We call the square root of negative 1 I. So if you were to square I, it will look like radical negative 1 times radical negative 1. Oddly, I squared would simplify as negative 1. It's a very interesting concept. I squared is the same thing as negative 1. On every problem, make sure you circle I squared, drop an arrow, and a parentheses negative 1. Negative 30. So you're rewriting I squared as negative 1. So you're replacing it, substituting. You're substituting I squared with negative 1. Then do a little squiggly to show that you're taking negative 20, add 10. Negative 20, add 18, add 18. Negative 20, add 18 is negative 2, and then your I. And then bring your 12 down. Negative 30 times negative 1 is positive 30. Don't skip steps because most kids do and they will get the answer wrong. 12 plus 30 is 42 minus 2i. 42 plus 2i is your answer. I think I did it right. 42 minus 2i. Yep. Let's make sure you circle. Let's do another one. 5 plus 8i times 3 plus 2i. We're timesing it. I times 3 is 15. 5 times 2i is plus 10i. 8 times 3 plus 24i. I also see kids not write the I. There's a whole I there, so don't not write it. 8 times 2, right? 16. I times I is I squared. What do we do next? We're going to simplify, right? So we're going to circle the I squared. You got it. Drop it down and substitute negative 1. Drop your positive 16 down. I'm telling you, do that every time. Squiggle, squiggle. 10i plus 24 is that 34? 34i. Drop your 15 down. Like put your plus. And then do this math. 16 times negative 1 is negative 16. 15 plus 34i. So underline like terms. 15 minus 16 is negative 1. Add 34i is your answer. If it asks you for your B value on a test, the B value is 34. Okay, now go ahead and write the term complex conjugates. What is a complex conjugate? Let's try 8 plus I times 8 minus I. You're going to see something here. Same thing, 8 times 8, 64. 8 times negative I, negative 8i. I times 8 plus 8i. I times negative I, negative I squared. Be careful about this. Watch. This is plus and minus, so it's negative I squared. What's our next step? You got it. Circle just the I squared. Drop it low as negative 1. Drop this negative down as a negative. Negative 8i plus 8i is 0i. You're done. 64, drop below. 64 plus 1 is 65. Your turn. You try. What is 3 plus I times 3 minus I? Pause the video and try it. All right, 3 times 3 is 9. 3 times negative I is negative 3i. I times 3 is plus 3i. I times negative I is negative I squared. What was next? You got it. Circle the I squared. Drop it low. Negative 1. Drop what? Yep, the negative. Don't forget about it. It doesn't disappear. Negative 3i plus 3i is 0i. It crosses out. Those are, what do you call those? Inverse pairs, I think. Zero pairs. negative, negative, positive 1. 9 plus 1 is 9. 10. 9 plus 1 is 10. What do you notice about these two conjugates? Well, what's 8 times 8? 64. Interesting. What's 3 times 3? 9. Interesting. So, write this down. The product of two conjugate pairs of two complex conjugates is always a real number. Always. So if you have plus, minus like this, like the same thing but opposite signs like that, it's always going to be just a real number. It's never going to have an I involved. It's just going to be the real part. Because them I's, right, cancel out because it's positive and negative. They cancel. So automatically it's going to be just 65. And you could do it quickly. 8 times 8 is 64. We're adding the 1. 65. 3 times 3 is 9. We are adding the 1. So it's 10. Well, let's try another one. Do it in your head. What's 4 plus I times 4 minus I? Pause the video. You got it. 17, right? 4 times 4 is 16. You're adding 1 every time on all these problems. Do it out. 16. Negative 4i plus 4i minus I squared. Circle I squared. Negative 1. Drop it low. You're done. 16. Add 1 is 17. There you go. You know what I mean? Right? All right. Now let's go ahead and bring it to equations. You already know. That was just like the intro. No, that's the main lesson. Say you have x plus 2 squared. 3 times it equals 90. No, not 90. Let's do 120, 120, 40. Let's do, sure, why not? All right, what if you have 3? Let's make it negative 120. All right, write this problem down. We're gonna solve this quadratic. You're gonna find out that it's imaginary, which will involve a complex solution. It's gonna have a real part and a fake part, right? All right, imaginary, not fake. 3 times x plus 2 squared equals negative 120. Well, we wanna untrap the x. So this 3 is in the way, and this 2 is in the way, this 2 is in the way as well. We first have to get rid of this 3. So 3 times x plus 2, this is 3 times because it's 3 touching a parentheses. So that means 3 times. There's an invisible multiplication operation that's going on there that you can't see, right? This means multiplication. So undo multiplication by, got it, dividing. Bam, get rid of that 3. Divide it over here. So you're left with x plus 2 squared equals 3 goes into 12 4 times, right? Cool. Now we gotta get rid of this square. How do you get rid of a square? How do you get rid of squaring? Yep, square rooting. So you're left with just 6 plus 2. And then you're taking the square root of negative 40. What did I just say? It is impossible to take the square root of a negative number. Impossible. Impossible, okay? So we call the square root of negative 1 I. Let's go ahead and break this apart. Take the imaginary out. We're going to rewrite negative 40 as negative 1 times 40. It's the same thing. The imaginary is now out of the question. I. Now we can go ahead and do our tree. 4 times 10, 5 times 2, 2 times 2, and keep your pairs. Twin comes out. Non-twin stays in, 5 times 2 is 10. I is put in between like that. So it's the real, and then your I, and then your radical 10. X plus 2 equals, right? X plus 2 equals radical negative 40 should be rewritten as 2I radical 10. You can double check your answer. You can square the 2 back. What is 2 squared? 4. What's 4 times 10? 40. Always double check your answer. Is X by itself? No. So let's subtract this 2 by undo adding. So you have to subtract it over here as well. And there's your x-intercept. There's your solution. Your solution. Remember, frocks. F rocks. F rocks, or frocks like crocs. Solution can be called a factor, a root, a zero, an x-intercept, a solution, right? This is your solution to this quadratic equation. Subtract the 2 on the other side, plus or minus 2I radical 10 is your answer. Okay, your turn. Negative 4 x minus 3 squared equals 80. Go ahead and try it without my help. Go ahead and solve negative 4 times x minus 3 squared equals 80. Pause your video. All right, this negative 4 got to go. This square's got to go. This 3's got to go. The first thing that has to go in order is taking away this negative 4 times, right? So we undo that by dividing. Divide this side as well. So that's negative 20, right? How do you undo the squaring? And by square rooting, right? X minus 3 equals the square root of negative 20. Break this down into your 5 times your 4, 2 times your 2. Twin comes out. This is imaginary. Write that, make sure you know that. Imaginary. Non-twin stays in. It's always plus or minus. X minus 3 equals. Is X by itself? Nope. How do you undo subtracting 3? Bam. Bye. Add it. X equals, add the 3 on the other side, plus or minus 2I radical 5. We don't write add 3, and it looks funny. You just say 3, right? You don't say, I have add 3 in my bank. I have positive $3 in my bank. It's not necessary. I have $3 in my bank, right? But you have to say I have negative 3. Now that's different, right? Okay. There's your x-intercept, your solution, your root. 3 plus or minus 2I radical 5. Sometimes you get fractions. You might get negative 1/2 times x minus 7 squared, right? The same thing. You're dividing by 1/2. Dividing by 1/2. Now we don't divide by fractions, so it's better to say, it's better to do it like this. This is kind of weird. We times it by the opposite reciprocal. Times it by the opposite reciprocal. 27 divided by negative 1/2 is the same thing as saying 27 times negative 2. We don't divide by a half. That's not, we don't do that. I think in 6th grade or 7th grade, one of those grades, they taught you that we don't divide by a half. I don't want to say it's impossible, but you don't do that. It's kind of weird to understand. So it's the same thing as saying 27 times negative 2. Just flip it, okay? So you're just multiplying everything by negative 2 to get rid of this. and times this by negative 2. So 27 times negative 2, what is that, 54? Yeah, negative 54. And then you do the same thing like I just showed you, okay? So that's how you do, we can do it. Remember, take the I out, don't forget it. It's negative because you're going to be square rooting this, right? 9 times 5 or 6, 6 or 7, 6. 3 times 3, 3 times 2. Twin, where have you been? 6, 7. You're adding the 7, plus or minus 3, twin, comes out. Non-twin, 3 times 2, stays in. So the solution to negative 1/2 x minus 7 squared equals 27 is 7 plus or minus 3i radical 6. Okay. So that's complex numbers with also solving quadratics.